Alright, here we are back again doing trig. This is going to be section 4.1 and 4.2, where we're talking about the basic graphs, predominantly of the sine and cosine functions. Alright, now we've talked about these as functions before. Angle goes in, out comes a number called the sine or the cosine of that angle. But we're looking at these more like actual functions in the xy plane and showing as x, which is going to be the input angle, increases, what's the shape of these numbers that are coming out? All right. So here's the 4.1 notes to start. I'm going to look back at the actual filled in versions mostly, but one basic way to generate a graph is simply to find a bunch of points that are on the graph and then plot them. All right, so in this table, for example, down here, here's our inputs. Now, we are going to be graphing these things in radians. The degrees are here just as a reminder. And the graphs in particular need to be done in radians, and that's for future purposes, really, in terms of slopes and things like that, and steepness on the graph coming out right. All right, so to fill in this table, that is just a matter of plugging a bunch of numbers into your calculator and seeing what comes out. You can do it in radians or degrees, but we'll do the graph in terms of radians. And we're doing the sine function. So plug in 0, sine of 0 is 0. Plug in 30 degrees or pi over 6, sine of that is a half. We're going to write these as decimals, though, because we need to really know how big they are once we plot them. Plugging in 45 degrees, hopefully you remember these, 0.707. 60 degrees gives us 0.866, and 90 degrees gets us a 1. All right, now as you go through, you're going to see those values again. I'm just going to start plotting a few of them, and then we'll look at the whole thing. Now, at the highest value, we go up to 1. At the lowest, we go down to -1. And we just have these x's and y's then. So 0, 0. Oh, okay, here's 1/2. And our graph would have to be marked out. We're going all the way to 2 pi. This would be pi over 2. And we have these values in here. Here, for example, is pi over 6, pi over 4, pi over 3. They're all right in there. So we would have pi over 6 and 1/2 on our graph, pi over 4 and 0.7, pi over 3, 0.866, pi over 2, 90 degrees, we get a 1. And you could start to see some shape here if you were to play connect the dots. So as you go through, we would just fill out the rest of these values, plot the rest of the points, connect the dots, and you get a picture that looks like this guy right here. So you may notice that those same decimals show up again as we go through this range of values till we get back down to 0. And then you'd actually get the negative versions of those guys as you went through here. I just plotted a couple, the bottom point, and then back up to 0. But that is the basic shape of what we call the sine wave. All right, if you were to keep going now, like we've talked about, and go beyond 2 pi, all of these values just start to repeat each other. And this shape just keeps going and going and going as well. Okay? One illustration of what's going on here. So remember, hang on, let me back up 1 sec. If we think about the old unit circle, here's our angle, and we have this point on the unit circle. We have coordinates x and y, where x is the cosine of the angle. Here's our theta. Y is the sine of the angle. So what we're really plotting here is as theta goes around, as the angle goes around, this is the graph of the y coordinate on the unit circle. So as you go all the way around, your y-coordinate peaks at 1, comes back down to 0, goes into negative values, hits a low spot of -1, and then comes back around and it's at 0 again. And that's exactly what's going on when you trace this path. And one nice way to see that in an animation, so imagine this is the unit circle here, and my face is in the way a little bit. Over here, this red spot is going to trace out a path, and its height is going to match the height of the corresponding point on the circle. So I'm going to hit go, and this radius is just going to turn at a nice constant rate. And this point is going to move along at a constant rate, and the red point will just go up and down to match the corresponding spot on the circle, and you can see this shape come out just so nicely. There we go, now you can see better. So as this thing just goes in a nice steady circle, the vertical position of that point, that's the sine of the angle that the radius is currently pointing in the direction of. And that vertical position just comes out so beautifully on that sine curve. And basically anything that is moving around in circular motion like that, and we just looked at a whole slew of things that moved around in circular motion in the last chapter, the vertical and even the horizontal positions of those things follow this sort of shape, follow this pattern, right? It's definitely a up, down, but it's not straight up, straight down, straight up, straight down. There's a curve to it, and that shape is called the sine wave. All right. So, terminology that we use now. So number one, on the graph of sine, and we'll see the graph of cosine looks awfully similar in just a sec. The amplitude is the distance from the center of the graph to the highest point on the graph, right? Measured with a tape measure, it's also the distance from the center down to the bottom of the graph. That's called the amplitude. The period, now this is, like I said, a repeating function. It goes through this little wave, this little cycle, and then it just repeats over and over and over and over again. Right? And that's what we are seeing here. It does that wave one time, and then it just keeps going and going and going and continues that wave for forever. Now, the question is, how long is one of those cycles? And that the terminology for the length of one cycle is called a period. All right, and ours starts at 0, and in terms of radians, it goes all the way around the circle. All right, it does one full wave by the time it gets to 2 pi. So our period is 2 pi. And the other thing you talk about with these functions is where they cross the x-axis. And so that's what's actually listed here for the sine function. Period of 2 pi, an amplitude of 1. And here's the points where it crosses the x-axis. You can see here's the one at 0, here's the one at pi, and then at 2 pi, and then it keeps repeating at 3 pi and 4 pi and 5 pi. And if you were to go to the left, at all the similar numbers, similar negative numbers too. Now, cosine, which is the horizontal position going around the unit circle, it actually cycles through the same values, it just starts at a different spot, right? At 0 degrees, cosine is 1. So whereas sine is 0 at 0, cosine is 1. But then from there, the horizontal position on that circle, it just cycles through the exact same values. And so it has the exact same amplitude of 1. It has the exact same period, 0 to 2 pi, to get through one full cycle, and then it starts repeating. But it has different x-intercepts. And essentially, you can especially see this nicely when they're on the same graph. Here's the sine graph and the cosine graph. So sine graph starting here at 0 and then doing its wave. Cosine starting here at 1 and doing its wave. They are the exact same graph, just horizontally offset from each other. That's all. All right. So that's what they look like, the sine and cosine graphs. And these waves, these shapes show up in all kinds of applications. All right, now that's the basic graph of sine and cosine with an amplitude of 1 and a period of 2 pi. And what we will study then in future sections is what happens when we put some other numbers in with these functions and how that changes the amplitude and the period and shifts things up and down and left and right and stuff like that. All right, on the second page of this section, though, actually, are just about the other trig functions. And we're not going to look at them a whole lot. I just want you to see the graphs of them. Now, the nice thing about sine and cosine is that you can plug any angle in. We've talked about this before. Nothing bad ever happens. Those definitions from a long time ago, x over r and y over r, or now with the unit circle where r is 1, we're talking about just x for the cosine and y for the sine function, is that nothing goes wrong. You never divide by 0 or anything like that. But with the other trig functions, there are places where they're undefined. So, first off, the domain, the set of inputs for which the function is defined. For sine and cosine, all numbers you can stick in. Your calculator will never break down and say domain error when you use the sine and cosine function. Other ones, though, different story. Tangent is good old y over x. So if we're on the unit circle somewhere, come on, here's x and y. Tangent is undefined when we have an x on the bottom, when x is 0, and that's the same for secant. And that happens in degrees. It happens at 90 and at 270. In terms of radians, well, the types of angles you can't put in the tangent and the secant function are pi over 2, that's 90 degrees, 3 pi over 2, that's 270. The negative versions, and then this would actually go on to like plus and minus 5 pi over 2 and 7 pi over 2, etc., etc. Similarly, for cotangent and cosecant, they have a y on the bottom, so they are undefined when you get a 0 for the y coordinate, and that happens at 0 degrees and 180 degrees around the unit circle. So you can plug anything into cotangent and cosecant except for the ones that give you a y coordinate of 0, and that is 0 and then plus or minus 180 degrees or pi radians, 2 pi, and then it actually goes 3 pi plus minus 4 pi, 5 pi, etc. So what their graphs actually end up looking like are these 4 graphs that we have at the bottom here. And I labeled them. So the tangent graph looks like this, and these guys repeat as well, just like the sine and the cosine functions do. So here's tangent. Tangent of 0 is 0, so there's that starting point. And then basically it goes off to infinity. It's undefined right here at 90 degrees. And then it goes through negative values until it's back to 0. And so actually the tangent function has a period of just pi, and then it starts repeating itself. Same for cotangent, but a different shape and different spots where it's undefined. Secant and cosecant, you can see secant of 0 is 1, and then it goes off to infinity, undefined right here, goes through a whole bunch of negative values, undefined again, and then comes down from infinity, and this is the end of its cycle. So a period here of 2 pi. For secant, same thing for cosecant. We don't talk about the amplitudes of these guys because these functions all go off to infinity. They don't have like a top value and a bottom value. So they just go on and on for forever. Vertically, that is. But then they repeat on and on to the left and to the right. Okay. I think I'm actually not going to go to 4.2 in this video. I'm just going to call that good for 4.1, and we'll do a different video for 4.2.